welcome to the first video of Section 10. Here's a heads up. Section 10 is a highly mathematical section. You will need a calculator, and I strongly recommend that you not use a cell phone calculator, that you use a dedicated calculator. As long as it can do scientific notation, what type of calculator is up to you. We're going to set some goals for this section. The first is to be able to calculate the percentage of each element by weight in any compound. This is the percent composition. The second is to be able to use the percent composition to determine the mass of elements in any sample of a compound. And thirdly, to be able to use percent composition to determine the mass of a sample of a compound if you're given other information. It's important to remember the whole is the sum of the parts. You learned that in Section 9. And what you learned long ago was that percent is equal to the part over the whole times 100. Both of these concepts are important in this section. Percent composition is based upon the molecular weight of a compound. It's easiest to just step into an example. So we'll go with, what is the percentage of hydrogen in any sample of C12H22O11? Well, there are two simple steps. The first, determine the molecular weight of the compound. Second, calculate the percentage. So here we go. We've got C12H22O11. The molecular weight, which is step 1, I know I have 12 carbons, 12.01 grams per mole, 144.1 grams per mole with correct sig figs. For the hydrogen, I have 22 hydrogens, and my periodic table says the molecular weight of hydrogen is 1.008 grams per mole. So with correct sig figs, I get 22.18 grams per mole. I have 11 oxygens, I multiply it by its molecular weight, and with correct sig figs, I get 176.0 grams per mole. I'm now going to add these all up to get the molecular weight. The whole is the sum of the parts. I get 342.3 grams per mole. That's the whole. What I'm interested in is the hydrogen. The hydrogen weighs 22.18 grams per mole. That's the part. So now I take my equation, percentage equals part divided by whole times 100, plug in the part, plug in the whole. So I'm going to get this, which ends up being this, but I have 4 sig figs in the numerator, 4 sig figs in the denominator. So my answer should have 4 sig figs. So the correct answer is 6.480%. Okay, let's go to a second example. Suppose I have calcium nitrate, and I want to know what's the percentage of calcium in any sample of calcium nitrate. First thing I'm going to do, figure out the formula weight or the molecular weight. So I got 1 calcium, 2 nitrogens, 6 oxygens, and so the whole is 164.10 grams per mole. I'm interested in the calcium, so the part is 40.08 grams per mole. Now I'm going to use the same equation, plug in my values. Notice 4 sig figs in the numerator, 5 sig figs in the denominator. So my answer will have 4 sig figs. So I get this, which turns out to be 24.42%. We're going to use that percentage for the rest of the examples. What happens if I tell you how much you're given and want to know how many grams of the element are present? So for example, you are given 50 grams of calcium nitrate. In that 50 gram sample, how many grams of calcium are present? So first, ask yourself, what do you know? Well, you know the whole sample weighs 50.00 grams. From the previous example, we know the percentage of calcium is 24.42%. And we know the equation, percentage equals part over the whole times 100. Plug in what you know. So 24.42 equals the part divided by 50.00 times 100. Multiply both sides by 50 grams. To get rid of the 50 on the right hand side, you're left with this. So you now do the math and you get this. Divide both sides by 100 to get the part by itself, and you get 12.21 grams equals the part, which is the grams of calcium in the sample. Okay, we're going to stick with the calcium nitrate because we know the percentage of calcium. Now this time you're given the mass of the calcium. What's the mass of the entire sample? What do you know? The mass of the calcium is 34.54 grams. The percentage is 24.42%. We know the equation. We know the part. We know the percentage. So put them into the formula. Now you're going to swap the 24.42 and the whole. That's the down and dirty way of doing this. So it rearranges to this, which when you start doing the math goes to this, which goes to this. So we have 141.4 gram sample. That's all you have to do. So to review, the whole is the sum of the parts. The percentage is the part over the whole times 100. If you know any two of the three variables, percentage or part or whole, you can calculate the third. And the percent composition for a compound is the same for any size sample. In the next video, we're going to begin to work backwards, and given the percent composition, we're going to start to work towards figuring out what the molecular formula is.